Hi, this is Dr. Pan recording from Tucson, Arizona. Today we have a question from one of our YouTube subscribers. Let's do an analysis and solve this one. To send your own questions, please consider subscribing our channel. Alright, so here's analysis, roots and vertexes. For the purpose of this problem, I went ahead and graphed this one. I thought the graph would show you a lot better. So for our case, roots is really to say when does the curve, this red curve, cross the x-axis, because that's where y equal to 0 or function equal to 0. Obviously, we can see 2 points here. Now, vertex is an entirely different matter in that we need a complete square and put in a special form, and the vertex here for our case is all the way a minimum point over here. That's over here. So let's see how we're going to put all those together and find a solution for this problem we're given. So let's solve this problem in two parts. Vertex is over here, roots is over here. Roots, like we explained earlier in analysis, is just setting function equal to 0. Now, factoring this one requires a little finesse in that the coefficient, the first one is not equal to 1. You can use quadratic equation, but over here I thought I'll show you some different method. This method is called a fishing, in that you're going to pretend you're going to factor x squared minus x squared minus x with the coefficient 1, but put the 5 times 4 on the bottom back over here with the coefficients. This one is pretty easy to factor in that x squared minus x minus 20 factor to be x minus 5, x plus 4. When you come out of this fishing bubble, you're going to retain the form minus 4 and plus 4, minus 5 and plus 4, but instead of x, you're going to have a 5x to match what you had before. Since 5x times 5x is 25x squared, we're going to divide it by 5. Now, I know this looks a little complicated, but it works all the time. It's like magic almost. So simplify over here a little bit. We have x minus 1, 5x plus 4, and if you want to check to make sure the answer is works over here, you can FOIL it out. You can see the 5x minus 5x squared minus x minus 4 is retained. Now, once we factor this, the rest is pretty easy. X equal to 1 or x equal to minus 4 over 5. Those are the two roots. Alright, in finding the vertex, what we're going to do is rewrite the equation over here. We're not going to be solving anything. The reason we're going to rewrite into this form, it will become very apparent quickly. Basically, once we have in this form something squared minus a constant, once we set the first term equal to 0, the answer, the minus 81 over 20, becomes the smallest possible for the function. Thus, it's called a vertex over here. Now, how do we get into this form? It's a little tedious, but nothing difficult per se. What we're going to do is going to pull the 5 out because I need a coefficient of x squared to be 1, and then I factored the 5 out over here, so it's x over 5. Now, this number I'm about to underline in white, that's the special number I added to make the perfect square. Thus, it's called completing square. The perfect square, this magic number, is half of whatever the coefficients in front of it is. Technically, I do have a minus sign, but since it's a square, it doesn't change anything for me. Now, once we have half of this coefficient here, square it, the combination of the 1, 2, 3 terms give me a perfect square, which is x minus 1/10 squared. Since I added something over here, I need to compensate it by subtracting it out so I don't change my equal sign over here. Now, when you're compensating this white part, be careful with the 5 because the thing that I added in here is inside the bracket over here. To compensate, I need to multiply by 5 to make sure nothing changed. Combination of the 3 inside the bracket give me a perfect square. Now all I have to do is clean up the numbers, coefficients here a little bit. It's minus 4, those are constants. Minus 5 times 1 over 100. A little bit of simplification is 81 over 20. This is called a vertex form because this square term, the smallest it could ever be is 0. And that happens at x equal to 1 over 10. And when that happens, this chunk goes away. The smallest the function could ever be is minus 81 over 20. And that's where the vertex is. Well, I hope this helps. Hi, this is Dr. Pan recording from Tucson, Arizona. Please comment, share, or like this video. Together we can make math easy again. Have a confident day.